Hi everyone, in today's video we will study about analog input. So we already studied about a digital output. So okay, and that is done actually. So let's say a mark star. So analog output we didn't study it, and digital input we didn't study it. And today's video we are going to have on analog input. So out of the four types, the first type is done, and we are going to study this AI. So A0, that means AO and DI has to be done in further tutorials. So keeping them apart, so we will study about analog input on today's video as a second topic. So let me paste it first. Oh my god, what I have done. Okay, give me a minute. Okay, right. Oh, this mess up. So we are going to study about this today. So the rest we will study in upcoming tutorials. Okay. So we are going to study about analog input. So what actually is an analog input is we are going to take obviously input values, but not digital values, analog values. So analog values can be anything, right? 0 will be 1 there, 1 will be there, 1.2 may be there, 2.5 may be there, things like that, right? 5 may be there, 3 may be there. So like a graph that is going up and down, we can have any values as a analog values. So if you don't have much idea, just go to the whatever we call just go and have a look on the difference between digital and analog signals, and you will get some ideas. So that's fine. So now before we start on analog read, I want to tell you something. That Arduino has a capacity. What it does is when it reads an analog value, it breaks the value into 0 to 1023 into the numbers, right? Okay, so I will tell what it is actually, or we can also say it breaks the value into 1024 pieces. Okay, so 0 to 1023 means what? It starts from 0, no? So it is actually 1024 units. If it starts from 1, it should go up to 1024, but it starts from 0, so 1024 units will be ending at 1023. So that is clear. So in simple term, what we can tell is if we give the values, voltage values from 0 to 5 voltage to an Arduino whatever the pin, okay, that 0 to 5 voltage will be converted into the values that start from 0 to 1023. So obviously, not obviously, actually there are no decimal values will be given to them since they are units, 1024 individual units, and it goes from 0 to 1023. So we will have unit numbers 1, 2, 3, 1, unit 1, unit 2, unit 3, like that. Okay, so 3 units, 2 units, 5 units, like that. So basically whatever the analog value we are giving, we are basically giving some voltages. Even you are taking a sensor or whatever, voltage is coming. Then from the voltage, that Arduino, when we are reading the analog values, that Arduino, what it will do is from the 0 to 5 voltage, it will create 1024 units by itself. That means 5 voltage, it will break into 1024 units. Okay, and it will allocate the particular number of units to the value and give us the value. Since we know this process, what we can do is using that whatever the Arduino giving unit values, we can go back and understand what is the voltage value. So if you don't understand, I will tell you a simple example. So as I said, that 0 to 5, right? 0 and 5 up to from 0 to 5 voltage is broken into 1024 pieces, like that I said you, right? So if you are giving 5 voltage to any Arduino as an input, analog input, if you get that input value and if you serial print the value, you will see 1023 will be printed. Why? Because as I already said, we broke that 5 voltage into 1024 pieces. So that means that start from 0 to 1023. What is this happening? So 0 voltage will be 0, and the maximum 5 voltage will be the maximum value. You understand what I am talking about? So when it is 5 voltage, all the 1024 units will be allocated, and Arduino will say, okay, this is 1024 units. Okay, that means 1023 value because it starts from 0. So if there is 1024 units, you will understand the 5 voltage input is given. Let's ask a simple question. If it is 512 units, what is the voltage you are getting inside as an input? It is the half of the total number of units. That means the half of the voltage. So that means 2.5 voltage. You understand? I hope it is understandable. So, and also when it's 512 units, what is the printed value that Arduino can give you? Because it starts from 0. So that means 512 minus 1, 511 is the value. Okay, you are getting. So let's ask another simple question. What if the Arduino is giving 255 as a analog? When you are giving a voltage, it is giving 255 as the analog value. I mean, from in this context. So 0 to 255 is the number of units Arduino saying this much of analog input is coming. So that means what? Actually 256 units because it starts from 0. So total number of units are 255, but like, yeah, total number, the value you are getting is 255 and the total number of units are 256. So that means what? 1/4 of the a quarter of this 5 voltage. Quarter of this 1024 is 256, right? That means we have divided the 1024 by 4. That means the voltage is also divided by 4. So that means we are getting 1.25 voltage as an input. Okay, so that because 125 is something quarter of 5, like that the quarter of 1024 units will be received as a value, right? Will be shown as a value. I hope you can understand. So if you don't understand what I am talking that much, you can simply think we are getting 0 to 5 voltage as analog input. So analog inputs we are using reading through in analog pins. So if you are giving a voltage that is ranging from 0 to 5 to the analog pin, so that 0 to 5 voltage Arduino automatically will break into 1024 equal units. Okay, so and then depending upon the number of upon the value of the voltage you are giving as an analog input, what Arduino will do is it will allocate the particular amount of units. So I said 0 to 1023, that means 1024 units. Voltage value 0 to 5. So 5 voltage will be the maximum unit number. So okay, 5 voltage will be actually 1024 units. That number will be 1023 because it starts from 0. Likewise, the minimum will be 0, voltage will be 0. There's no doubt on that. So you can even simply, what you can do is if you divide 5 by 1024, you can understand the value of the one single unit. So I hope this can be understandable. If you don't understand that much, when you are doing more practicals in analogRead, I will again explain you the things so that you can understand. So then only I said, okay, so what if the value is half of this 1024, then the voltage is the half of 5 voltage you are receiving, that is 2.5. What is if the analog value you are getting, what if the units is 1/4 of 1024, then the voltage also, that means the voltage is coming, the coming voltage is also 1/4 of 5 voltage. So that is understandable because the minimum amount of range is 0 and maximum value is respective to the 5 voltage. I hope it is understandable. So that will be in a way. Then what we do is we basically since we are taking an input to an analog input, we are going to use an analog pin. So let's say I'm going to use analog pin A0. So A0, A1, A2, A3, like that, there are analog pins, right? You know that, right? So let's say I'm going to use pin number A0. So as I already said you, when it comes to Arduino, we have to first say whether we are going to take that particular pin as an input or output. So in this case, we are going to take that particular pin as input. So what I will do is to mention that we have a keyword called pin mode. Okay, you know that. Then I will open and close and I will pass the pin number. So since this is A0, you just don't worry and pass A0. And then you have to say it is either output or input. When it comes to Blink, we say it as an output. But since we are taking an input here, we are mentioning it as an input. That is understandable. Okay. Okay, so and also, so this is a comment actually. Okay, A0 input. And now we are going to read the analog input values. So to give that output as the digital write output, I said as a digital output, I said we have a digital we have a keyword called digital write. So like that, now we are doing the opposite thing, opposite of digital and opposite of the output, because we are going to take analog input, both are opposite. So for that we have a keyword called, to take analog input we have a keyword called analog write, sorry, not analog write, analog read. So now you know a new keyword called analog read. So remember, wherever you are going to read the analog value, you are going to use this exact keyword. So like digital read, digital write, now we have analog read. So same opposite, right? So don't worry, it's understandable. We are going to read the analog value of a pin, and let's say the particular pin that I said as input, I'm going to pass a pin value, pin here. Okay, so A0. The thing is, when it comes to digital write, what we did is we pass the pin, and also we pass the pin the value in high or low. But since this is an input, we don't have any values. Okay, so we don't need to pass any values, we just have to pass the pin. We are going to take input from this. But there is one more thing you have to do when it comes to inputs. The problem is, when we are giving an output to a particular pin, the output is given, that is very simple. But when you are taking input from a particular pin, so every moment the input is coming, right, you can read. So what are you going to do with that input? Are you going to store it? Are you going to do something with it? Are you going to compare it? So you have to do some mathematical operation with the input. If you just have this word, it will read it and it will lose it. Okay, the Arduino will read the A0 value and it will immediately lose it. We don't have a way. So what we have to do is we have to basically save that data in a particular variable at each and every moment. So what we do is we will assign a variable value, and we know the values are going from 0 to 1023 and they are pure integer numbers. The analog values that whatever the voltage you are giving, the Arduino is going to break it into 1024 pieces and it will give you the number of units. Okay, as I said earlier. So this unit will be integer values. So I can simply define an integer value. Okay, so what I will do is I will say int x. Okay, and I will give a semicolon here. I am not giving a value to this, because what I am going to do is this variable, that analog read value, I am going to assign to this particular integer. So what I will do is, as we already did, because earlier what we did is we say anywhere we want, we say x is equal to 10 or 20 or something. So like that, now we are going to give a value to x, but not a particular fixed value, but the value that is the analog unit. So simply we are going to say x is equal to this value. Whatever the value comes, please assign it to x. Like we are assigning pin number, like we are assigning 10 or 100 or 20, like that. Whatever the unit value coming at that particular moment, assign it to x. And we know this unit value will be somewhere between 1000 to 0 to 1023, including the limit values 0 and 1023, including 0 and 1023. Any value can be there, any full numbers, that means no decimal numbers. So that suits with the integer data type, right, x. So we assign x to analog read A0. So now we store this analog read value at a particular moment. It can be any voltage, anything, right, whatever it is, to x. So then what will we do? We can compare the x with some threshold value and we can give an output, or we can decide something, things like that we can do. But basically what we'll do is we will try to print the x value. So the x will be a value that is somewhere between 0 to 1023. So to see that, we have to print that value. So you know how to serial print. So you have to go to the void setup and you have to start the serial communication. Okay, and you have to write the speed. Okay, then here once you assign the value x to this void analog read, once you assign the analog read value to the x, you have to serial print the x. That's it, because x is the value of the analog read, whatever the A0 value, right? So you have to serial print x. That's all you have to do. So you have to use a semicolon, obviously, there's no doubt on that, x. So now you will see A0 will be A0 pin will be read for its analog input, and that whatever the analog input value, whatever the read value will be assigned to x. And you already know, since this is somewhere between 0 to 5, you will get a number that is somewhere between 0 to 1023, depending on the voltage value. So x will be assigned to the particular value. That means the particular value will be stored in a memory location that is named as x. So when you serial print the x value, that particular value in that memory location of x will be printed, or whatever the x integer value will be printed as here. So that means the serial read analog value will be printed. That x means the analog read A0, right? That same value will be printed in the serial monitor. So since the void loop is running very fast, where in a very fast manner you will keep reading that analog read values. So what you can do is you can do a simple test. You can connect you can use a mail to mail header, and one side of the mail header, what you can do is the jumper wire, mail to mail jumper wire. So one mail header you have to fit inside 5 voltage pin, and you have to connect the other mail header into A0. That means you are giving 5 voltage input to A0 analog pin, because to read analog values we have to use analog pins. So you are giving 5 voltage, and then we read that A0 value, actually analog read that A0 value, and then what we do is we assign it to x, and we will serial print the value. And you will see, since this is 5 voltage, because Arduino is separating that 0 to 5 voltages, Arduino is breaking and assigning it to break into 1024 pieces. So when you are saying 5 voltage, it will be 1024 units. All the total 1024 units will be there. So 1024 units mean what is the value? 0, because it starts from 0. The 1023 is the value, because 1023 is the maximum value, and 5 voltage is the maximum voltage we are giving. Normally we can give according to the logic. So 1023 will be printed. You will see that. So then what you can do is you can connect to ground, and that A0 pin you can connect to ground and see what happens. Then you will see 0 voltage is printed. So if you can give 2.5 voltage to the A0, and you will see 511 will be the serial printed value, because 2.5 means half of 5 voltage. That means half of 1024 units. That means 512 means this range starts from 0. So 512 minus 1, 511 will be there. So that kind of scenario you can actually try. And if you know how these if you can create an equation between these units and these voltages, and then you can even print the voltage also by adding a simple mathematical operation somewhere here, okay, like adding or something. That means by having a equation, and then you can print that original voltage value as well. So what I want you to tell you is and also know that this 1024 units are divided just for somewhere between 0 to 5 voltage only. You cannot give 100 voltage and see that analog value, right? So you may damage your Arduino. So we always consider this, whatever sensors we are using will be somewhere between 0 to 5 voltage. Okay, so 5 voltage is the maximum voltage we are considering as that means 5 voltage is the voltage we are considering as the maximum voltage, and 0 is the one we are considering as the minimum voltage. So that is why we broke our whatever that analog values into 1024 units into 0 to 5 voltage. So if you want to know what is the value of one particular unit, you can simply divide 5 by 1024, and you can understand what is the voltage value of one particular unit. Okay, so I hope you can understand. Even if you don't understand, in one of the upcoming videos I will show you a picture of how it is how the voltage are divided, and then you will understand. Okay, so if you don't understand that video, then have a look on that video that will be coming soon, and then come back to this video and you will understand. For this moment, I hope you can understand what actually these lines are meaning. So if you are confused, that has to be only with that 1024 and 5 voltage. If you even understood that, that's great. If you don't understand, we will have it in upcoming videos as well, and then you may have to come back to this video. So I hope you got something from the video. So until I catch you in the next video, have a great day ahead. Bye.